Now two important results to find a limit of function. These functions contain exponential functions and logarithmic function. See, this result is limit of e raised to x minus 1 upon x is 1 as x tends to 0. Say here e raised to x. Say here I am putting space. E raised to x minus 1 upon x. Limit x tends to 0. It is equal to 1. I have replaced x by this box. So whenever we apply this result, here x can be replaced by any variable. If you put here y, then there should be here y. If you put here z, there should be z. If here it is 5x, this should be 5x. So that is the application of this rule. Now look here, limit x tends to 0, e raised to 4x minus 1. See, in this function you can see here there is 4x. Now according to the rule, whatever is here, same number must be here, same number, ditto. So whatever is here, same number must be here. So here there is 4x, so here there must be 4x. So e raised to 4x minus 1 upon 4x, and if 4x tends to 0, then its limit is 1. But here x is given, not 4x. So what we do? To set here 4x, we multiply by 4 and divide by 4. We cannot change value. Now 4 is constant, 4 I am taking outside. Limit e raised to 4x minus 1 upon 4x. Now x tends to 0, so 4x tends to 0. Now compare this expression with this pattern. E raised to box minus 1 upon box tends to 0. E raised to box minus 1 upon box tends to 0. So this is equal to 1. So 4 into 1, that is 4. So rule means here x is a variable, x can be replaced by any function of x. Any function, you can put here any function, fx, here fx, so here there should be fx tends to 0. So this is application. Now say here e raised to x minus e raised to 5 upon x minus 5 is given. To apply this rule with e raised to fx, here there should be minus 1. 1 is required. So what we do? Here to set 1, here we want 1. So what I am doing? Taking e raised to 5 common. Taking e raised to 5 common from numerator. So first term will be e raised to x minus 5 minus 1 upon x minus 5. E raised to 5 is taken common. So inside the left numbers will be here. We have to put e raised to x minus 5 minus 1 upon x minus 5. Now e raised to 5 is constant, take it outside. Limit e raised to x minus 5 upon minus 1 upon x minus 5. Now look here, x tends to 5. When x is going near and near towards 5, it means their difference tends to 0. So difference of this number tends to 0. And you can see that now the pattern is obtained. E raised to fx e raised to fx minus 1 upon fx, fx tends to 0. E raised to fx minus 1 upon fx, fx tends to 0. So this is 1. So e raised to 5 into 1 is e raised to 5. Now here in third question, see, as we discussed this rule, similarly here x can be replaced by any function. X can be any function of x. So here limit of log of 1 plus fx. Now x I am replacing by fx. So here this should be fx. So fx tends to 0. It is equal to 1. Whatever is here, same number must be here, same number must be here. If this is y, this should be y, this should be y. If this is z, this is z, this should be z. Limit is 1. So x can be any function of x. So that is application. Now here, see, log of 1 plus fx, this is in place of fx. So to apply that rule, same number must be here. This is 2x and here x is given. So to set the same number, what we do? Multiply by 2, divide by 2. So this is equal to limit x tends to 0, multiply by 2, divide by 2. Multiply and divide by 2. Now look there. 2 is constant. 2 I am taking outside. Then put limit log of 1 plus 2x upon 2x. See, fx is now here, fx is 2x, and x tends to 0, so its double tends to 0. If any number is going near and near towards 0, then if you multiply that number by 2, then product is also going near and near towards 0. So the pattern is here set. Log of 1 plus fx upon fx, fx tends to 0. So by that rule, this is equal to 1. So limit is 2. Now next question. Limit of e raised to sin x minus 1 upon x, x tends to 0. Say e raised to, there sin x is given. So here function is sin x. So to apply this rule, if here sin x is given, here we require sin x. E raised to sin x minus 1 upon sin x is 1 if sin x tends to 0. So what we do here? This is equal to limit x tends to 0, e raised to sin x minus 1. Here x I am putting inside. X is separated. Now to apply this pattern, to create this pattern, this is sin, here is sin x, so here we need sin x. So here divide by sin x, multiply by sin x. We cannot change value, so divide and multiply by sin x. And now you can see that, so this pattern is obtained. E raised to fx minus 1 upon fx. Now if fx tends to 0, its limit is 1. So here x tends to 0, so sin x tends to 0. So that will be 1. Now here this is f, this is g. Limit of fx into gx is limit of fx, limit of fx into limit of gx. By working rule of limit, limit of fx into gx is limit of fx into limit of gx. Now x tends to 0, so we can say sin x tends to 0. Therefore, by this property, see fx, 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 sin x, sin x, sin x. So this is equal to 1. and the limit of sin x upon x, x tends to 0 is also 1. So here limit is 1. In this question, so limit x tends to 0, look this pattern. Whatever is here, same number must be here. Application of this result. Whatever is here, same number must be here, and same tends to 0. So say here log of 1 plus x square. This sin cube x I am putting inside. Now to set this pattern, here x square is given, so we need here x square. So what I do, divide by x square, multiply by x square, multiply and divide by x square. So say here correction is required, this should be sin square x, this should be sin square x. Now this is equal to limit x tends to 0 log of 1 plus x square upon x square into, this can be expressed as 1 upon sin x upon x whole square. Sin x upon x whole square. That number can be expressed as, shifting this number in denominator, here sin x upon x whole square. So now applying limit of f into limit of g. So limit of log of 1 plus x square upon x square. Now x tends to 0, so x square tends to 0 into 1 upon, now limit of this function, limit of sin x upon x, x tends to 0 whole square. So therefore this is 1 into 1 upon 1 square, so value is 1.